The role of the forest sector in the bioeconomy. Forests are of vital importance, covering 30% of the terrestrial land surface. 1.6 billion people are dependent on them, and they host 50% of all terrestrial species. Forests have considerable tangible value, from the $327 billion worth of forest products, providing over 60 million jobs directly, to the huge range of non-timber forest products, such as medicines, with an estimated value of over $100 billion. Nevertheless, the intangible values bound up in the ecosystem services that forests provide in controlling the water cycle, in soil conservation, and in the provision of 40% of the world's oxygen are presently undervalued, and forests, in addition, store 66% of all terrestrial carbon. Therefore, actions to slow, halt, or reverse deforestation from the present rate of 12 million hectares per annum must be implemented to protect this immense natural capital, whilst at the same time we must satisfy the increasing demand for wood, estimated currently to be 3 billion cubic meters per annum and predicted to increase by 25% by 2020. Let us look at how planted forests are part of a multidimensional solution, driving up socioeconomic impacts whilst reducing environmental footprint. Any realistic climate change strategy must by necessity invoke a comprehensive forest plan. Avoided deforestation could provide 5.8 of the estimated 17 gigatons of CO2 equivalents necessary to keep atmospheric carbon concentrations below the critical 450 parts per million, of which planted forests could provide 1.5 gigatons. Sustainable reforestation could utilize the 2 billion hectares of degraded land that is available for reforestation, of which 75% is in Africa. Establishing planted forests on degraded land could significantly contribute to soil restoration, since nowadays, through highly sophisticated forest management practices, approximately 34% of all biomass produced is returned to the soil, and careful planning of harvest cycles further minimizes soil erosion. Integration of plantations with agriculture can avoid food security issues, providing an additional income stream for farmers, whilst a mixture of legislation and voluntary management decisions help stabilize local and global hydrological cycles. In Brazil, between 30 and 40% of land acquired for forestry is set aside as legally protected reserves for biodiversity, totaling 3 million hectares of protected forests in 2010, providing an interesting case of how industry pays for externalities and remains profitable. In other parts of the world, plantations are being used for the control of desertification. In this example in northwestern China, native woody species are being studied for the potential to reverse desertification as well as for providing economic return by biomass accumulation. If we are to build a resilient, low-carbon future for a world that must operate within stringent natural resource limits, scaling up and replicating plantation forestry models, particularly in the least developed countries, is an imperative. Transitioning to the future we want will require concentrated multi-stakeholder actions if sustainability impacts are to be achieved. This will require a vibrant forest sector based on sustainable, scalable business models, transformed by scientific and technological innovation, including massive investments in advanced breeding, silviculture, biotechnology, and downstream processing technologies to improve and protect yield and generate an explosion in the diversity of biomass-based industrial products. This will only be possible, however, if the sector can transform itself through closer public-private partnerships, leading to the creation of a web of research cooperations, germplasm exchanges, and closed-loop value chains. Let us be in no doubt about the cost of engineering this bold transition, which will decouple unsustainable consumption and production practices from growth. A blend of public and private sector funding, as well as direct investments by industry, will be required, and governments must establish stable and predictable policy frameworks encompassing science-based regulatory mechanisms, technology development incentives, policies to promote payments for environmental services, and policies that stimulate greater public sector-funded research, since currently government funding for agriculture and forestry research amounts to only approximately 10% of government funding for human healthcare research. Inclusivity is essential. The design and implementation of this transformation will require the active involvement of the rural communities who will be the stewards of the plantation forests, the new generation of biorefinery workers, and the consumers who will benefit from the more suitable products and services this network will provide. And finally, the convening power of the United Nations multilateral system, with its mandate for implementation of the Rio Principles, Agenda 21, and now with the Rio +20 commitments to Sustainable Development Goals, has a key role in implementing this common vision. The successful assembly of this multi-stakeholder web could yield 5 highly significant impacts. Firstly, avoided deforestation. Secondly, with stronger scientific and technological innovation, the tools, skills, and knowledge base for ecosystem restoration would be available. Any large-scale initiatives that raise primary productivity have immediate and long-term benefits for rural development and rural social protection. More efficient primary productivity is a key driver to sustainable forest intensification and more resource-efficient value chain creation. And finally, the potential for biomass-based industrial development translates into a plethora of opportunities for novel, carbon-neutral, sustainable industrial products such as platform chemicals, composite fibers, and plastics, the base of the bioeconomy. Let us now consider how recent advances in biotechnology could drive this transformation by yielding more from less. As seen in this chart, developments in breeding and forest management have provided steady improvements in yield, and coupled with parallel advances in processing technology, the amount of land needed to produce a given quantity of pulp has decreased. Yield intensification does not adversely affect key sustainability indicators when careful planning and management practices are applied. Water use efficiency in well-managed eucalyptus plantations compares well with other crops grown in similar soils, and eucalyptus is also efficient in its use of soil nutrients. These improvements have been incremental over the last 40 years, but are reaching a point of diminishing return. What is needed now is a quantum leap in yield. Biotechnology offers a suite of options to the forest sector that sustainably increase yields and productivity. Conserving today's resources for tomorrow means that sustainability must be built on productivity intensification. Yield-enhancing technologies increase output to meet the demands of increasing human population, lower the industrial footprint, and decrease demand pressure on natural forest resources. New genetic technologies can protect forests and allow us to adapt feedstock for more efficient processing and to tailor feedstock for specific offtakes, thus reducing environmental chemical load. New biotic and abiotic stress resistance technologies will be vital tools for the survival of crops in the face of rapid climate change. Where tree biotechnology will truly find its place will be in the emerging bioeconomy, since here lies the potential to revolutionize product diversification and value chain efficiency and break the association of GDP growth with fossil fuel-based carbon emissions. Current economic models utilize lignocellulosic resources for high-volume, low-value products. The bioeconomy will couple a modified lignocellulosic resource with advanced biorefinery technology to produce new high-value bio-based products and replacement products. The Biopathways project of the Canadian Forest Products Association identified a potential market of more than $200 billion per annum for such products. Thus, for the forest sector, the future we want can be envisaged as a constantly evolving network of stakeholders, united through interdependent actions towards a common, impact-orientated vision. Collectively, these actions could mean that deforestation is slowed halted, or reversed. Ecosystems are restored and rural development is realized. Underpinning all of this will be sustainable, technologically advanced plantation forests, driving a global bioeconomy that reduces fossil fuel dependency and breaks GDP growth from carbon emissions. FuturaGene stands ready to support initiatives around the world in making available its knowledge and experience, and to actively participate in the design and implementation of the pathways of innovation and sustainable development goals. Collaboration, governance, and innovation will be the new pillars of sustainable development.